astronomy and cosmology, it's this great topic. If you're going to be an astrophysicist, awesome. But your life is affected every day by all this exploration going on in space. We started with the Big Bang because I would figure if we're talking about space and everything, we should start with maybe where it started. And as the universe expands, we kind of talked about the creation of maybe the first elements and how all those things coalesce to form the first stars, how stars, their life cycle is, how they're born, how they die.
Space is a very dangerous place.
Oh, yeah.
And the evidence shows there are countless pieces of debris all around us. But the odds of a 5 to 10 kilometer wide asteroid like that, thing that wiped out dinosaurs, it's actually at the point where it's 0.0000001%.
So it's still possible.
It is still possible.
Jesus.
Right? We're not saying it can't ever happen, but the likelihood of that happening is pretty slim.
And ultimately, what we want to talk about is life in the universe. Statistically speaking, there's got to be more life out there. So
We're building rockets, put water in it, and we're going to put so much air in it that the water's going to come out of the bottle and it's going to push the bottle upwards.
I'm gonna put,
Oh, nice, a little umbrella.
yes.
Now, our little drink umbrella's aerodynamic.
I have no idea, I just found them in the closet.
no, that was a great hands-on project. And as we were getting into talking about the solar system, I paused and thought, why don't we talk about quickly how we just get stuff into space? This has no water in it, all right? Really no added mass to it yet. When I'm pumping air into it though, am I adding mass? Yeah, in the form of just air, right? As it pressurizes and pressurizes, it's eventually, hopefully, right? So all that mass pushing out the back has the opposite reaction, right? So what law was that of Newton?
Third.
The third law, right. So now I've put more mass to this already with water. And this is where the fun begins a bit. All right, what happens if we put more in? That's what we're going to find out. All this groundbreaking science happening right
Push that
now.
on there so it's nice and tight. Don't want
So it'd be a great way to introduce the kids to what it takes to get to space and the fact that it's not easy, but it's still worth doing.
Oh, God!
How's science feel? Yeah.
Oh, I'm good. I'm wearing this jacket.
I was nice and put warm water in this at least.
I'm just waiting for it to just like suddenly. As I was saying.
There's a direct connection between talking about it and having it happen, isn't there?
Yay!
Yay! I love science.
All right, who wants to get soaking wet next? I mean, launch their rocket next. Oh, nice. That went really well.
Nice.
All right, so Salem's is doing really good. So we saw 100 grams, it went pretty good. We had more mass. We had more thrust, it went higher. So here's Salem's rocket with 500 grams.
Yeah, that went nowhere.
Not too far. That went really nice. Woo! Now you get it, yeah. All right, who's next? What did we learn there?
Charlie doesn't like getting wet.
Oh, I think it was the opposite. Charlie doesn't mind getting wet.
Any rocket comes back down, it doesn't always burn up all the way. And one guy, I forget what year it was, but a farmer found like a chunk of rocket in his farm. Pretty well intact, actually.
This rocket debris lands on man's farm in Washington. This stuff is supposed to burn up in the atmosphere. So, why is it that the moon, though, is covered in craters, impacts, and we are not?
They erode and stuff here on Earth.
They do erode here, absolutely.
Because we have the protective atmosphere that makes it.
Okay, it's traveling through space between what, like 15,000 to 50,000 miles per hour?
It's an ongoing assignment where every week the kids have to find a current event that's astronomy, cosmology related.
A bunch of satellites up in, is it the atmosphere or is it like in space?
Space, yeah.
Okay, so it's up in space. There's supposed to be more access for like rural areas in the Northeast Kingdom for internet and stuff.
Technologies are constantly growing and it trickles down to the civilian sector.
This is after they get launched up. They all get released in what's called like a train. And sometimes, if you're lucky enough, you can actually see this. I got to see it once. So this is definitely a problem, especially if, related to Jalen's article, all these Starlink satellites have to be sent up there.
It's a great way for us to kind of steer the course in a different direction. If everybody's article has to do with, say, the Mars landing, then I know, there's a lot of interest in Mars. So let's spend a little extra time there. Let's really, really digest it.
So what are we building today?
Cup rocket.
Coffee cup rocket.
Making it very bright yellow,
Okay.
so I don't lose it. Is that what we're gonna do? We launched rockets! We had a small rocket engine with a solid fuel.
And then you can pull it out.
Yeah. The hard thing is having enough room to be able to do that without deforming the rocket too much. Because if we
And I got blown away by them because they built their rockets in the course of 2-3 days.
We had to make the blueprints, then we had to make,
The fins,
and then we had to,
sand them, cut them out.
we had to make all the parts and stuff, and then put it all together, and then boom, rockets.
So like you look at it straight through the straw, and then you follow it upward, and once it goes upward, you take this, and then this should be the angle that it goes up at.
If we take 70 from 90, because we start at 90 on that,
Right.
and it angles back to 70.
So 20.
So it'd be 20 degrees. We could use trigonometry to figure out how high these rockets actually went, right? So when you're standing at this point here, and you're looking up at this point, what are we gonna create?
A triangle.
Yeah, a right triangle. And right triangles are fantastic for this.
I kind of said, maybe a week or two this will take. But they were just so into it and just so excited about doing this. So when the wind gets calm, all right, we'll make sure they're ready. You hold this and hold that. Got it? Yeah. Okay.
Holy crap!
Oh God.
There it is!
I'm the master of getting things stuck in trees.
That one you couldn't even see.
The tree!
Poor Matt. I really feel bad.
No, literally, I threw 3 sticks to get it and they all landed right next to it. It was stuck in a tree. I was like, are you joking me?
He took it well. I mean, he screamed for a while, threw sticks, and then accepted defeat.
Seriously, you could not.
I can't say he accepted defeat either.
No! My rocket! It's ruined.
How about the tail fins? They
They're
look like
twisted.
they're, at a slight angle. So what are you aiming to do with that? What's that going to do?
Spin!
Spin how?
Spin!
Mine corkscrewed like a psychedelic bullet.
My slow down mechanism was going to be an umbrella so that the rocket wasn't going to pop off like everybody else's.
It demounted from there.
Yeah, it ended up blowing a hole through my umbrella and ejecting the engine out the back.
So the SS coffee cup.
SS coffee cup. Here, don't let him point at you.
Definitely wouldn't say the aerodynamics of a coffee cup are great.
Look at that landing, though. Look at that landing.
A worthwhile experiment.
Definitely.
And everything went right, but, everyone had a good time.
Yeah. It's a typical school day at EVS.
Don't always launch a rocket. Played the song Rocket Man to the footage of the rockets being launched. That'd probably be the best way to do it, maybe. I don't know.
Man, they think I am. No. I'm a rocket man. Rocket man.
Matt, you're on camera. Oh! They've caught my whole plan.
The whole evil plan. Tell us your evil plan, Matt.
I'm gonna make a missile.
A missile. Well, what does missile mean?
That's a good question.
One of the best things is they're taking an ancient Greek class, but as we're going through, students are recognizing, hey, I know what that word is.
I think this one's Latin rather than Greek, so you might not have run into it, but it's something you send. Like a mission.
When we're talking about Mars, the two moons, Phobos and Deimos, I'm probably saying them wrong, they recognize him like, that means fear and people.
So if I like send like a postcard or something, right?
Yes.
Am I sending a missile?
Yeah.
Oh,
Well, you're sending, usually the word we use for that is missive.
learning on camera, the more you know.
On a test, a student actually wrote the English words and underneath wrote it in ancient Greek. So I'm just like, this is wonderful. This is fantastic. We are living in a time where we're making new discoveries every day. There's really cool stuff being discovered every day. Coming up, I have a project that they're gonna get that I'm really excited about. It's talking about the alien life, where students get to pretty much design their own planet with their own alien life and really try and use the best of their imagination, what they know from our previous course in ecology. It was a great way to kind of blend our fall semester course of ecology into astronomy and hopefully get them thinking about what they've learned and blending it all together into just one project there.
We'll probably be back up on Tuesday to do. We all need to go back to school, buddy.